Hello, and thank you for working through the UKCA tutorials. I'll just give you a little bit of background information on those and on UKCA itself. I'm Luke Abraham. I'm in the National Centre for Atmospheric Science. I'm based at the University of Cambridge. So what I'll talk about today is what UKCA is and what you can do with it, what these practicals are, and what some next steps after you finish them. So UKCA is a climate chemistry aerosol model, and it's built as part of the Met Office unified model. And I think it's important to remember that it's not a particular collection of chemistry and aerosol schemes, but it's a framework for putting chemistry and aerosol schemes into the unified model. It was originally designed for long integrations covering decadal and centennial timescales, but it can also be used for air quality forecasts. And a number of different chemistry schemes that currently exist, covering the troposphere and the stratosphere. And these schemes are provided because the UKCA developers have wanted to use them for a particular purpose. If they don't suit your needs, you can do new things to them, you can add new things, you can modify them, you can make completely new schemes if you wanted to. And the aim of these practicals is to teach new users how to do this. So these practicals make use of Global Atmosphere 7 and the Rose Silk interface at UMvn11.8. There are a number of differences between these and some of the previous versions of the practicals which you may have seen. And these jobs are a cut down configuration designed for training and testing. So the configuration is a bit simpler. In terms of how it runs, it just runs a 3-hour job in about 7 or 8 minutes. It won't allow for cycling to allow you to do multiple days. It has a low model top at around 40 kilometers, and it has a course resolution of N48 L38. Most climate jobs that you run will be at least N96 L85. So what resources are available for people who are using UKCA? So I'll talk a little bit about the UKCA evaluation suite, a bit about NCAS CMS, and of course there's also the Met Office Science Repository Service that you all have had accounts on to be able to run these tutorials. And what Mozzers does is provide access to the UM source code and suites used to run the UM. There are lots of information on the UM wiki pages, and there's also the full set of UM documentation papers. So you can see the UM Mozzers pages at that address there. So you've decided to use UKCA, but if you're the only person at your institution using it, it can be difficult to get up and running with it. And it can be difficult to overcome and solve model problems. So these tutorials have been developed to address this kind of first problem of how to kind of get up and running. You can also run the UKCA evaluation suite, which is on the Met Office desktops, Monsoon 2 and Jasmine. The second issue can be addressed via CMS if you're outside the Met Office, and they answer queries. And I'll talk about those in a little bit. The UKCA evaluation suite is developed by Mohit Dalvi, and this takes existing scripts developed by different academic groups developing UKCA and combines them into a single package. And generally speaking, the UKCA climate jobs will output a set of standard diagnostics, which you can then feed to the suite and produce a series of plots to help with model evaluation. Inside the Met Office for their own development practices, they've got other tools like AutoAssess and ValNote, but they don't necessarily cover all the details of the chemistry and some of the aerosol that we'd be interested in. So the evaluation suite is a kind of nice addition to those if you're running the big climate jobs. So what does this evaluation suite output look like? This is a kind of example showing how we were assessing different jobs through model development. So we have our very old version, UM7.3 with a course resolution. And we can see we've got some problems with our nitric acid and our age of air. We find that when we move up to a new model version, but keep the same chemistry, things improve slightly in both avenues. And then when we move up to Global Atmosphere 7, which is the same configuration as you'll be using here and is similar to the UK ESM1 science settings in some respects, a lot of these problems have been fixed or are reduced. NCAS CMS provide the Puma service. So this runs the UMUI and Rose and Silk servers, which are used to submit UM jobs to Archer 2. They provide training. Some of you may have done that training, and this is both as an online tutorial and as a 2-day workshop. They provide tools such as xconv and xancil. You'll be using xconv in these tutorials, and the CF Python library, which is kind of similar to Iris in terms of its functionality. They manage the NERC atmospheric group on Archer 2, which is called NO2, and many of you will be running under that if you use Archer 2. And they also importantly provide the CMS Help Desk. So the CMS Help Desk is a way that you can ask questions about various problems that you might have, and they will go to the team of NCAS CMS, and they will answer these questions. So this is a problem I had quite a while ago now, where I was having an issue with some branches and I was having an issue with FCM. So I raised a query on the help desk, and Ross Hatcher was able to help me solve it in 5 comments. The help desk is searchable, so if you have a problem, the first thing you can do is search from past tickets for the same problem or keywords. And if you can't find a solution, open a ticket, then this is emailed around. Generally speaking, UKCA tickets will be answered by me. It might be that you think it's a UKCA problem, but actually it's more of a system problem, and then someone else might pick it up. So the premise of these tutorials is what are the most common things that a PhD student or new researcher will need to know how to do when they start using UKCA. And there might be questions like these, what happens when you add in a reaction to form a new species? What are the effects of changing emissions? How does deposition affect these processes? What happens to the aerosol properties when you do these various things? What are budgets through various processes? And when you completed these tutorials, you should have a basic understanding of how to make these required changes and answer these questions. And you'll be asked to perform a series of tasks, and in fact they're part of one big task, which is to make 2 new species called Alice and Bob. You add in some emissions of Alice, and you add in a reaction of Alice with OH to form this species Bob, and a kind of secondary organic compound that links with the aerosol scheme. You add in dry deposition of Alice, wet deposition of Bob, and output the fluxes through the reactions and the deposition processes, and then you diagnose what's happening to the aerosol. So to a certain extent, this encapsulates a lot of what you might be asked to do with this model. Despite seeming straightforward, they're actually quite a big task. There's lots of changes. There's lots of changes in rows. You're editing the stash master A file. You're editing some metadata files. Your changes to the diagnostic output to output new things. You're adding new species, new emissions, making up new emissions files. You're adding new reactions and deposition. You're regridding this data to make these files. You're creating these netcdf files, and you'll be processing some output using Python. When working with UKCA, it's important to break these tasks down into manageable chunks and test them regularly. So don't try and do everything at once. Split them across various tasks like the tutorials do. So, get it working as it is. Know that it works there. Commit your changes so that if you have to backtrack, you can, and then carry on to the next bit. And also remember, UKCA currently sits within the framework. So some things you need to do the side first. So when you're adding in traces, you need to kind of turn them on in the before you do anything with the UKCA side to get them to be interfaced in UKCA. And if you try and do the UKCA stuff first, you would never get it to run, but you can often get it to run by turning on the side things first and then getting UKCA to work with them. These tutorials are broken down into kind of 3 sections. A general use of UKCA in rows. These cover the basics for copying and running a suite before outputting the field through stash. Then we're focused on chemistry, and this is broken down into kind of 6 chunks because there's quite a lot going on there, which also covers emissions, as well as adding tracers, reactions, dry wet deposition, and chemical diagnostics. And then we'll look at aerosols, and this is quite a big tutorial covering various different things, changes to stash again, analyzing some output, performing a little sensitivity experiment, that sort of thing. They've been designed so you can go through them in your own pace and at your own time. And this is partly because people work at different rates. You might find one problem much harder than someone else. You might find another problem someone else finds hard much easier. So don't worry if you have some problems. That's natural and expected. And don't worry if you think you find it too easy either. That's absolutely fine too. I've tried to give some guidance as to how hard the problems are and how long these problems might take to do, but these are just a rough guide. Everybody is different.